absolute value handout, and if you don't have the absolute value handout, you'll want to write down the important information from this part up here. And you're still going to want to go through the whole activity. You're just going to need to do it on a separate sheet of paper. So basically, instead of me just saying, hey, here's what it does, you guys are going to use your graphing calculators as tools to look at how these graphs change. Okay? Notice first at the top of the page, there is an absolute value function. So the directions at the top are not to be ignored. They actually give you some valuable information. So if you don't have the handout, you're going to want to make sure you write down that equation. If you do have the handout, you're going to want to make sure you highlight it, circle it, whatever the case may be, because that equation is an important piece of information. So it's y equals a, and then it has x minus h inside the absolute values and plus k. All this is basically saying is that we're going to write our absolute value functions in a form where they are y equals, and the equation's on the right-hand side. And we know that we like equations to be so that we can plug in a value for x and get a y value, which means we would expect numerical values here at a, here at h, and here at k. Okay? Those numerical values are going to affect the function in different ways. Okay? So, I don't know, maybe this turns it upside down, or moves it over, or makes it wider, or makes it narrower. We want to know what those things do. So our goal here is to use the technology to understand how the functions work. But then we should be able to graph almost as fast as the calculator can, because we understand how the function works and what it should look like. So what we're building in this class is this idea of not only do we study a function as an equation, okay, and what goes into that equation, but we should immediately have associated with that a picture in our head of what the graph looks like and how it acts as you change the numbers that are in this equation. Okay? So it's not just a standalone equation. It's going to be connected to an image, and we're going to understand how that image would change as numbers in this equation would change. Does that make sense? Okay, that's kind of our goal and what we want to be able to identify. So instead of us doing them all on our own, we're going to go ahead and do them in the calculator. Before we do them in the calculator, if you look at your handout, it has one of them provided for you. So I want to talk about how they came up with the a, h, and k values. So on the handout, what it does is it gives you an equation. Then it asks you to find the a, the h, and the k value, to sketch a graph, which you're going to get off of your calculator, to say where the vertex is and whether it opens up or down. So look back at the equation that we just talked about. This y equals a, x minus h, and plus k. How did they determine that in this number 1, when it just says y equals the absolute value of x, how did they determine the a value was 1? Yes? Good. Okay, so a represents a number multiplying the absolute value of x. So what number, if it's not written there, could be there and not change the value is 1, like she said? Okay? All right, so how did they decide the h value was 0? Yeah. Good. Okay, so there's a certain number that if we multiply things by, they are unchanged, which is 1. But there's a different number that if we want to add or subtract two things without changing them, it's 0, right? So when there's nothing written here, it can be the same as me subtracting 0 or adding 0 on the outside, which is why h and k were both 0 in this case. Is that okay with everybody, how they identified the a, the h, and the k values from the equation? Then the next thing they do is they already sketched this graph for you. Now, on this graph, or actually next to this equation, can you guys please go and write that this is the parent function? What a parent function is it's kind of the simplest form of the function, completely unadjusted, meaning there is no a, h, or k values changing anything about the function. So it's the most basic shape of the absolute value function that we're going to use. Okay? Then when we discuss other absolute value functions, we'll see that they should generally have the same shape as the parent, but they're going to have been adjusted by the A, H, and K values. Okay? All right. So to get this graph on your calculators, okay, I want you guys to go to the y equals menu. And the first thing I want you to do is we don't want anything that's already there. So any equations that are listed in the y equals menu, clear them out. And if at the top of the y equals menu, your plot 1 or plot 2 or plot 3, if any of those are highlighted because they're on, because we were doing statistic stuff, you need to scroll up there and press enter on them so that when you scroll away, they are not highlighted, okay? Because otherwise it's going to try and plot all that statistic stuff, and we're not looking at that right now. We're looking at the absolute value function. Okay, so you're making sure in your y equals, when you go there now, nothing's highlighted. There's no equations in there. No plots are highlighted up at the top. Okay. Now what we're going to do is we're going to type in this equation. Okay. But you'll notice there's not like absolute value bars sitting on the keyboard for you to type. Okay. So on your calculator, there's an absolute value function, and it works more like a computer. Like, you got to go find the absolute value function and tell the calculator that that's what you want to use. So the way you're going to do that is make sure you're still in the y equals menu, because we want to be typing in our y1. Okay. So you're in the y1 section. Your cursor's right here, okay, waiting to type. To get the absolute value function, you are going to press math. And math is right underneath the green alpha button. Then when you press math, notice there's this menu for math, and if you scroll over to the right, there's 4 menus in total: math, num, CPX, and PRB. Okay? We are using the num, the NUM menu, because it's going to do stuff to numbers. And then notice what the first choice is in that number menu. Good, it's ABS, which is our absolute value function. Okay, so choose choice 1. Now, if you have newer software, it's actually going to give you the nice little absolute value bars and allow you to type inside of them. If you don't have newer software, then it's just going to say exactly what it said, ABS, but that just means put the stuff you want the absolute value of inside the parentheses. And for you guys that get the absolute value bars, you want to type what you want inside the absolute value bars, inside the absolute value bars. Okay? On the calculator, when you want to use a variable, notice next to the green alpha button, so next to it, so you're not going to push the alpha button, but that's a good marker. Next to it, there's a button that says X, T, theta, N, okay? And a lot of those might seem strange to you, but those are variables we use in different instances of math. For most of the time, you guys have been using X most of the time throughout your math career as you've graphed. So this will quickly give us that variable. So just go ahead and push that button. That should put an X inside your absolute value. Those of you that have the bars, you might just want to arrow to the right so that you're out of the bars and you're done. Those of you that don't have the bars, you just need to close the parentheses. Okay, and the parentheses is right above the number 9. And so now you should have the y1 equation entered and highlighted. Now, I don't want to just push graph right away because our windows are probably set from all that data we were working with before, which probably isn't the nicest way to see the absolute value function. We're going to go ahead and use a pretty standard window, and what they consider the standard window is when your graph basically goes from 10 to negative 10 in all directions, numbered by ones. Okay? And to get that quickly, we're going to go to zoom, which we've used before. We are not choosing zoom stat this time. Instead, look at choice 6, which says Z standard. Okay? That's what we want to choose. Then it should take you to your graph, and you should get the picture like you see right here. Are we good? Yes? Okay, I'll check yours in just a minute. All right. The next thing you want to do is you want to identify the vertex. What is a vertex? Eric. Okay. Where the 2 lines intersect each other. Basically, anytime something turns around graphically, we tend to call that a vertex. Okay? Later, we'll see that we call them minimums and maximums. So the vertex is where this turns around, which in this case is 0, 0. And notice that the absolute value function opens upward. Okay? So what you guys have is you have 6 more problems to complete, numbers 2 through 7. You have to identify the A, H, and K values. You need to identify the vertex and whether it opens up or down. but you can do that after you sketch the graph. So every time, you can just go back through typing the absolute value function. Remember that if you want to type something in front of the absolute value function, like if I want to type this function into my calculator, okay, I'm going to type in the number 3. I'm going to go get my absolute value function. Then I'm going to type x minus 2 and close it. And then I'm going to type plus 1. Okay? And remember that your calculator has minus for minus and negative for negative. So if you mix them up, you'll see different results. Okay? All right, so your job is to work with your group. Use the calculators that are there. If not everyone has a calculator, have the non-calculator people figure out the A's, H's, and K's. And then the calculator person can get the graphs for everybody to sketch, okay, and make sure your group can complete this relatively quickly. All right. I know that people are still working, but if you have the answers for 2 and 3, if you could please come and write them up here. Okay. If you're quietly finishing up, you can quietly finish up, but you should take a look at what's up here so that 1, we can check our answers, and 2, we can have a little discussion. So as we discuss this, if stuff occurs to you, I would make little notes next to each section, kind of comparing it to that parent graph and what's happening. So first of all, are we okay with the A, H, and K values for these 2 problems? Okay. So when we're looking at the graphs and comparing these 2 graphs to the parent graph, what are we really focusing on? Which part of the equation? So what changes in these 2 equations compared to the parent, Raven? The A value. So as we compare these graphs to the parent graphs, we've done nothing to H and K. We're really only focusing on how changing that value of A affects the graph. Okay? So based on what you guys see up here, could you make any conclusions on how you feel that A affects the graph, the value of A? Yes. Okay, so one observation is that if A is positive, the graph opens upward, and if A is negative, the graph opens downward. Okay, do we generally see that happening here? All right, any other observation between the change in these numbers? Yes. Okay, good. So the bigger the value of A, the narrower it is. Kind of independent of whether it's negative or positive, right? So there's like 2 things going on. There's the negative positive part of it that's just telling me up or down. And then there's like the number part of it, okay? Like this one right here with the A value of -2, is it narrower, wider, or the same compared to the parent function that we graphed? Eric? The same? Do we all agree? Okay, do this in your calculators for me. In Y1, graph just the parent function, the absolute value of x. And in Y2, graph, -2. Actually, let's take the negative off for a minute. So in Y2, let's just graph 2 times the absolute value of x. The reason I'm doing that is because what's the negative doing to this function? What's it doing to the graph? The negative part. Making it go down. I want you guys to look at the x, the absolute value of x, and 2 times the absolute value of x right next to each other and see whether they are the same width or if they are different. Okay? So graph both of these at the same time. Go ahead and press your graph once you have them both typed in. Notice I changed the 2 to a +2 because I want them to face the same direction. Okay? Are they the exact same width? No. Okay? Then the question is, which one is narrower, which one is wider? So if you guys, was yours graphed one at a time, like it graphed one and then it graphed the other one? So it graphed whatever you entered in first was what was put on the graph first, and then whatever you typed in second was put on the graph second. Okay, good. In these ones, we can say that the 2 and 3 are acting like a slope because they're linear. So these lines along your graph right here, this line has like a slope of +3, and this line has like a slope of -3 right here. Okay? 3 because 3 is that coefficient in front. So as that number gets larger, the graph is getting narrower no matter which direction it's facing. What do you think would happen if I put a 1/2 here at the beginning? Insha? Good. It would be wider than the parent function. Okay? All right. We're going to check our answers to the next set. So as we look at these, let's look at number 4 first. Are we okay with what we see here? Okay. What about in number 5? So a couple of adjustments we have to make, right? Just that the a value should be 1. I get that it's not there, but 0 times anything would have made it 0, and then just make sure we have our x and y in the right spot. But the idea is right. Okay, so what were we analyzing when we were looking at number 4 and 5? What part of the equation were we concentrating on trying to study? Was it the a value again? No. What were we kind of analyzing here? The k values, okay? And how did you see them affect the graph? Alex? Okay, it showed where the vertex started horizontally or vertically? So what do you guys think? He's right. This k value definitely affected the vertex. But our coordinate plane runs in 2 directions. There's a horizontal direction and there's a vertical direction. Was this k value affecting horizontal values or vertical values? Vertical values, right? We were seeing the y coordinate of the vertex change based on those values. Okay? Are we okay with this idea? All right, the last one we want to look at is h, and so just for sake of time so we can do the examples, I want to fill this in. So the a value is 1 and the k value is 0. Can anybody tell me what the h value is in number 6? Yes. Good. How many people thought positive 3 was a possibility? Yeah, okay, it's not odd to think that. We see a plus 3 right here, but what did the formula say inside the absolute value bars? Yeah, minus h. And you might think, like, that's so weird. Why would they do that? But you'll see why they did that in a minute when we look at the graph, okay? So to make this look like plus 3, you would be doing minus a negative 3 value, okay? And what's the h value then going to be for number 7? Positive 2, right? Because x minus a positive 2 would end up looking like x minus 2. Then when you guys looked at the graphs, how did these graphs compare to your parent functions? First, did they both still open upward? Yeah, we kind of determined that was determined by a, and we didn't change that. Okay. Where was the vertex of your graph for number 6? And what about our vertex for number 7? 2, 0. Now, this is why they did the crazy thing of making minus h in the formula, so it's super complicated for you to pick out the h value. It might be super complicated for us right here to figure out that that means h is a negative 3, but then it correlates so perfectly for our graph that that actually is telling us the x value of the vertex, okay? So these h values, they are shifting our graph or changing where the vertex is on our graph. Are these horizontal changes or vertical changes? Horizontal changes, because they're affecting the x coordinate. So here, like negative 3, 0 would be your vertex, and you'd have your v. And here, positive 2, 0, and then you'd have that shape. Okay? So after doing this, you should have established that what's the shape of an absolute value function? A v. Okay? Then you kind of know how a, h, and k adjust it. Yeah, Cody?
Why isn't it negative 2?
So remember that in the formula that they give you, it's a, and then in the absolute value is x minus h plus k. So this minus sign is part of the formula. So if you picked negative 2 as an h value, it would have been minus a negative, which would have then appeared as plus. So you need to pick positive 2, so it will still appear as x minus 2. Is that okay? All right. So then on the back of your handout, first of all, okay, so it says, Andrea thinks the absolute value function should be nicknamed the rebound function. What do you think she means by that? Why would somebody want to call it the rebound function? Good, because it kind of like bounces off, right? It goes a certain point, then it turns around and bounces off. Can anybody tell me why this function behaves that way? Why does an absolute value function calculate values all in a row, and then all of a sudden it turns around and goes the other way?
Because if the line were to continue to go, that would not, or the absolute value changes the number, so
So it's a distance away from 0. So think about just regular absolute value, right? If you were on a number line, and here's 0, as you were over here at -10, how far are you from 0? Just 10 spaces, then 9 spaces, 8 spaces, etc. Then you hit 0, but then you're 1 space away, 2 space away, 3 space away. So graphically what's happening is like, oh, I'm closer and closer to 0, I hit 0, and now I'm getting further and further away from it. Okay? So you can write whatever explanation you want in there. Yes, Alex? I don't know. All right, how can you predict whether the graph of the equation is upward or downward? Yes, Raven. Good. So if A is positive, and mathematically you're going to see that written as being compared to 0. So if A is greater than 0, we would expect upward. If A is less than 0, we would expect downward. If A was equal to 0, you would no longer have an absolute value function, which is why we don't include that case. Okay? Okay, so in the next 3 sections, you guys can go back through. We talked about all these answers. So how does the value of A affect the graph? You would want to see part B to know the negative and positive goes up or down. What was the other effect that A had on our graph? Yes? Okay, so good. It has to do with the slope of the lines. And when you looked at A without the sign, so if you looked at A as an absolute value, okay, just looking at the number, if it was bigger than 1, then the graph became more narrow. And if it was less than 1, then our graph would be wider. Okay. How did the value of h affect the function? So if somebody missed today and they came up to you and said, oh, what does h do in this case? What would you tell them? Minsha? Good. So it's the x-coordinate of the vertex. And so like she said, basically what's happening here is this is being shifted left or right. And then how would you summarize for somebody what k is doing in this case? Alex? Good. So k is the y-coordinate of the vertex, which means it is causing shifting up and down. Okay. Any questions about how the equations put together and how those a, h, and k values are going to affect your graph? Okay, then turn your calculators off. Now that you've seen all of this stuff, you should be able to quickly graph these functions by hand without the use of technology and know what they look like because you know what all these different values do for each part of the graph. Okay, so first problem. If we were given a graph, could we write the equation? And then we'll do, if we have the equation, can we get the graph? And I know it's a little hard to see the axis on here. But you guys have it on your paper if you have the handout. If you're trying to write an equation for this function and you know that it's an absolute value function, you know you're trying to put it into this form. So somebody give me a piece of information that they would be able to get from the graph and fill in immediately to the equation. Yes?
The vertex.
Okay, good. So if I identify the vertex, it's 2, 1. Okay? And then somebody else tell me how that's going to look in my equation. What is going to go where? If I know the vertex is 2, 1. Somebody new. I see Raven. I see. Yes? Good. Our vertexes are h and k. Right? So it's going to be x minus 2 inside the absolute values, and then plus 1. Right? So then the only other thing I need is my a value. Eric. So we can look at the slope of the line. So try to find another place that you see it cross well. I don't know. It crosses right here pretty well. So if I look at this, I can determine the slope of the line. So it looks like it has a rise of 1, well, actually going down 1, and then going over 1, 2, 3, 4. But if I had measured it from the other side, I would still get 1 and 4, but I would have a positive slope instead of a negative slope. So I know that my rise over run should be 1/4. How am I going to determine if I should make it negative or positive? Because with the absolute value function, you have a line or a segment of a line, one with a positive slope, one with a negative slope. Huh? Good. So you look at the graph. What do you guys think? Should it be positive or negative a value? Positive. Okay? Not so bad to graph it by hand, right? Because as long as you know all those things that you discovered, it's pretty quick. All right, so we're actually going to look at example 2. The reason we're going to look at example 2 is what? Why do you think I chose this one if I'm going to make you go through and graph it? You have enough information to go graph absolute value. The A is 1. Okay. What else about it, Raven? Yeah, so this does not fit our little mold of how the equation should look, right? But the cool thing about absolute value is that if I had the absolute value of 3 times 2, it's the same thing as the absolute value of 3 times the absolute value of 2. Okay? It has that property because absolute value only is going to change the sign of the number. So does it matter if you make them both positive before you multiply or if you make the answer positive at the end? Are you still going to get the same number part of it? Yeah. So what we're going to do when it sits like this is we're going to factor what's inside the absolute value, specifically taking out that coefficient of x, whether it goes evenly into the other terms or not, because we need the x to not have a coefficient. So I'm going to factor a 2 out of what's inside the absolute value bars. What am I going to have left in here? Good job. Okay, so I will have left x minus 2. Okay. And now I'm going to see that as the multiplication problem, just like what's right here, meaning I can write the absolute value of one of those factors separate from the absolute value of the other, meaning 2 can be in its own little absolute value bars multiplying by x minus 2. And x minus 2 is a bit of a mystery to me. I don't know whether it's negative or positive, so what absolute value is going to do to it. Mm-hmm. Yes. So this is going to become our a value, and it's just going to become 2. I know that because I know the absolute value of 2 is 2. I don't know the absolute value of this because it would depend on the x value plugged in. So that's why that part can't come out of the absolute value bars so easily. So we have our A, our H, and our K. Is our H value positive 2 or negative 2? Positive 2. So your vertex should be at positive 2, positive 3. Okay. And what should the slope of my lines be? 2. Should they go upward or downward from this point? Upward. So if I go up 2 over 1, I can see the line going this way. Then I have to actually go up 2 and over negative 1, or think of it just like when you graph a quadratic like you guys did in Algebra 1, like you're mirroring the points on the other side to get the other line. But when you're done, you shouldn't have lines crossing and going in all directions. You should have a clear vertex point, and your V should either go completely up or completely down from that vertex point. Okay? So do you guys feel like you understand how the absolute value function works? You could look at a graph and know if it was absolute value and how to write the equation, and you could take the equation and you could graph it yourself. Okay?